Hey everybody! In this tutorial video, we're going to do a deep dive in setting up object audio maps in QLab 5. Let's get right to it. There are conceptually a few different kinds of maps you might want to build. You might want to build a realistic map that's trying to represent a real physical room as accurately as possible. You might want to build a map that represents an abstract design space, or you might want to build a map that represents a kind of a mix between those two things, somewhat realistic but with some abstract design touches built into the map. QLab 5 can cover all of those kinds of maps, and we'll look at those now. Before we get into setting up the map specifically, I want to remind you that audio output patches are still where you define the routing from the Q outputs to the device outputs. This is an important piece of the puzzle, and it stays the same in QLab 5. If we look at the audio output editor, we'll still see the same output routing matrix where we take Q outputs and route that to device outputs, and that allows me to decide what Q outputs relate to speakers in my room. We're combining maps with these output patches to make the magic happen, but the routing still happens in the Q output patch. So now let's go look at the actual maps. There's a new tab in QLab 5 of audio maps. I've got a couple here that we'll play with, and I'll open up one that is empty, and we'll talk about everything that's in this window, all the pieces of it. Settle in. First of all, of course, the map has a name. I've called this map My Cool Theater. The map has dimensions. It has a width, which is this dimension, and a height, which is this dimension here. Now, those dimensions, does that number mean anything? Not necessarily. By default, it doesn't. It has no unit. It's not meters, it's not centimeters, it's not feet. If you want it to mean those things, you are certainly welcome for it to do so. You could choose for those numbers to represent real units and measurements in the world. But by default, it's just a unitless number. Have it whatever you want. You can edit it later. You can make the map smaller or larger. That's fine. You can change it as you go. This bit of GUI here is the test object GUI. It allows us to play a test object and listen with our ears about how this map is sounding. We'll come back to that very soon. This button on the top right is the monitor button. If I click on that, I get a window which shows this map and all active objects within it. Any objects which are active in the map from any cues or any other sources will show up in this map where they are, so I can see at a glance for the entire workspace in this map how many objects are currently running. There aren't any right now, so it's empty. So we'll close it again. On the left side here, we have a table of marks and filters. I'll talk about exactly what those are very soon. If we switch over to the second tab, we have a table of map objects. I'll talk about those a little later. Back over on marks and filters. At the bottom of the window is a miniature inspector. If I have a mark or filter selected, I can change the properties of that mark and filter down here at the bottom of the window. I can also show which output patch I'm currently referencing as I edit this map. Maps aren't tied to a single output patch, but the output patch you use them with is important because the output patch defines how Q outputs are routed to the device, remember? So just in the same way that a matrix mixer is a mixer to Q outputs, an audio map is a mixer to Q outputs, and the patch that you're using at the time that you use that audio map is defining how those eventually get to speakers. So the output patch matters, but it's not tightly tied to the map. Each Q will pick an output patch and a map, and putting them together is what makes the final result. I also have a little pop-up button to select a heat map, which we will see in just a moment. So let's start putting some stuff in this map. Conceptually, what am I about to do? Well, QLab takes the approach that you're going to give it examples of how you want things to sound at different places in this map, and it will use your examples to decide how to do the routing. This allows you to mix realistic and abstract ideas in the same map. So I'm going to give an example, and we call the example a mark. A mark has a location and a set of levels associated with it. I'm going to add a mark with this button down here. It shows up in the middle of the map, and by default, it is silent. And this says if the object is at this location, at this yellow X, it would have these routing levels to Q outputs, which is silent all the way across. I can edit all kinds of levels for this mark, which means that if an object were at this location, now it would go out to multiple Q outputs at that location. Whatever way I want it to sound at that location, it will sound like that there. If an object is exactly on a mark, it will sound exactly like that mark. If an object is between different marks, QLab is going to do a mix of influences from both marks to come up with the routing at locations that you haven't given it an explicit example. So let's do a simple version here. I'm going to use a shortcut. I'm going to right-click on my map to add a mark that goes to just Q output 1. That's a very common need, so we made it easy to do that. And I'm going to add a second mark that goes to just Q output 2. And I'm going to be building up a somewhat realistic map, but I'm going to pause here with just these two marks and look at how these marks behave before we add more. How do I decide or understand how this map is going to behave? This is, at the moment, sort of like a left-right panner, basically, but how do I know that and how do I know how it's going to behave? I could play the test object, or I can visualize it with a heat map. Let's go to the heat map for the moment. And my heat map shows me one Q output at a time. I'm going to select Q output 1. Aha! Now I see this beautiful pink-purple swirl of color. And what is this telling me? This is saying in the lightest part of the color, in the lightest part of the heat map, this is all areas where Q output 1 is between 0 and -3 decibels. If an object is in this lightest part of the heat map, Q output 1 will be set at 0 to -3 decibels. These lighter or darker colors, as they step down, each of those darker colors represents -3 decibels worth of difference in this particular Q output that we're visualizing. So I can also hold down the Option key and see the very specific levels at the location of the mouse. So if I hold down the Option key and move my mouse around, I will see all of the actual output levels that QLab would compute for that location on the map. Now, this heat map is telling us some things about the behavior of objects in this map. I can also show a Q output 2 heat map. So that's Q output 2, that's sort of an inverse. And it's showing me that if I have an object moving between these two marks, I'm crossfading essentially between Q output 1 and Q output 2. So far so good? What do these other properties of marks do? Oh, I'm so glad you asked. The gravity of a mark represents the influence of that mark on its surrounding area. So if it has a high gravity, it asserts more influence in the nearby area. If it has a low gravity, it's a little more meek. It asserts less influence. If I increase the gravity of both of these marks, you'll see that I don't have to bring an object as close to Mark II for it to start to sound more and more like Mark II, because the gravity is high for Mark II, and therefore I don't have to get as close to it for it to sound like Mark II. If you have two marks that have high gravity, they're both asserting dominance, and they're squishing the area in which the crossfade happens to a narrow part. So if they both have high gravity and you're moving from one to the other, there's a narrower range in which it crossfades between the two examples. So this is a way that you are starting to be able to shape how objects behave as they move through your examples that you've set. Let me bring the gravity back down to 1. A little more modest assertion there. And we also have this property called shadow for a mark. Now we can already see something that looks a lot like a shadow in this existing map. What this represents is that if the object is on this side of Mark II, effectively Mark II is shielding it from the influence of Mark I. So because I'm looking at Q output 1 heat map, it's showing me that Q output 1 does not land in this part of the map because this mark is shielding the influence of Mark I. And that creates this shadow effect. And I can increase that shadow. I can go from 0, where it effectively is linear, all the way up to a maximum of 90 degrees. A 90-degree shadow creates something like a big old wall saying, "You shall not pass my influence at this mark beyond my shadow." Let's bring that shadow back down to 0. So those are two ways of shaping the map using marks with gravity and shadow. That gets me pretty far. I'm going to keep building a semi-realistic map with these ideas. Let's talk about a rough approximation of a standard off-Broadway or standard theater. I'm going to have the top of my map represent the stage, the bottom of my map represent the house or the audience, and I'm going to put in some fairly typical speakers. I might have some upstage speakers here that are up in the stage. I might have a center speaker at position 5, a center speaker, which could be a cluster of speakers, remember, because this is a Q output. Q output 5 could be routed to multiple device outputs in the patch. And then in the house, I'll give it some surrounds around the house on both sides for some fun effects if I want something to sound like it's surrounding the audience and not coming from stage. Okay, I've made a rough approximation of a fairly standard theatrical layout. Now, notice that I said a rough approximation. Does it matter that this is rough? Oftentimes, not actually. I was surprised when we first started testing this to discover that it really sounds pretty good, even if you're not all that precise about things, because you're just giving it examples and it just kind of works out. You can be precise if you want to, and we'll talk about ways of being more precise, but I would encourage you to play around with just putting stuff down, seeing what it sounds like. If it sounds good, you are done. That's all that matters, right? So we've got this layout of speakers, and let's see if we've decided that we're done or if we're happy with it. I'm going to look at the visualization of the heat map again, and I'm going to go around. There's my center speaker. If an object is on stage or in the audience, it might still go through the center speaker. And I notice up here, oh, there's a problem here that I want to change. I'm noticing that if my object is in the house, especially on the left side of the house here, it might be still sending, or it would still be sending, some signal to Q output 3, which is a speaker on my stage. I, as a designer, don't want that. I've decided I don't ever want an object in the house to be coming out of speakers on the stage. That is a thing that I just have decided should be true. One of the things with our approach to object audio in QLab 5 is we wanted to give you control over how the final sound sounded. And if our algorithm came up with a solution for how it should be routed that you don't like, we wanted to give you tools to tell it what you did want. So this is a classic example of if I have an object here and it's coming out of the speaker, we want QLab to make it easy for you to say, never, never, ever, ever. If my object's in the house, I do not ever want to hear it on the stage, and vice versa. If it's on the stage, I do not ever want to hear it in the house speakers. So we'll look at some approaches to controlling that in this map. One way we could use it, we could control it, is with the shadow property that we already talked about. I could increase the shadow here and basically block off the influence of these upper stage marks. That works pretty well. That mostly blocked off their influence, but there's this little leak between marks 1 and 5 here where mark 3 is still causing some influence in the house. So I think I can do better than that. I'm going to put this shadow back to 0, and I'm going to introduce another tool that we haven't talked about yet, the filter. I'll add it and then we'll talk about what it does. I'm going to create a horizontal filter here. It is a line in your map and you'll see immediately what it does. Aha! The filter. The filter is a way of blocking the influence of marks. If my object is on one side of a filter, it will only pay attention to marks that are on the same side of the filter. If my object moves to the other side of the filter, it will now only pay attention to the influence of the marks on that side of the filter. The filter blocks the influence of marks across it, so I can effectively create independent areas of my map. And that's what I've done here. I've created a horizontal filter. It can be at an angle, but I want to keep it horizontal. And this filter is saying, block the influence of the marks on either side of this filter, and therefore I can see now if I have an object in the house, it will never ever go to a speaker on the upper part of the stage, upstage speakers. If I have an object on the stage, it will never go to a speaker that's surrounding my audience. That's what I want as a designer. This filter will let me have it happen. What else can I do with filters? Oh, you have such great questions today. I'm so glad you keep asking them. One thing we can do with filters will be easier to see if we make this map larger. Let's make the map 2,000 units wide. Now, what happens at the boundary of this map is an important question. Does it fall off to silence? Does everything explode past the boundary? No. This is just a place we stop drawing the map. It does not immediately go to silence if an object goes off the map. The influence of the marks continue on to infinity. There is no amount of distance that would cause a mark to eventually go to silence if it extends off in this direction off the map. That's pretty handy for not having an object suddenly and disastrously snap to silence if it goes off your map. But there are cases where I would want my object to sort of fade out as it goes farther away. This is another use for filters. I'm going to add a vertical filter this time over here, and I'm going to make it nice and wide instead of sharp. And what this filter is doing is saying if I had an object that's moving out to the left of this map, eventually it would start to fade out to silence by the time it got to the other side of the far edge of the filter. So I can put filters on all sides of my map and essentially create a bounding fence past which any objects would fade to silence, if that's what I want. Another fun use of filters. So I've created a relatively realistic map here. There's one last detail with filters, which is especially why do we call them filters? They're not just walls or fences. They also have the power to let some influence through. It's not talking about an EQ filter or an audio filter per se. This is an influence filter, remember. So we'll see an example of that in action. Let's say I add another mark up here, mark 10, and I'm going to look at the heat map for mark 10, and I see that it is being blocked by my filter just as I would expect. But let's say for some design reason, if I have an object in the audience, I actually do want it to be able to come out of speaker 10, which is what's been defined at mark 10. So I'm going to take my filter and I'm going to say, you are allowed to pass through the influence of Q output 10. Bada bing, bada boom. Now this filter blocks the influence of the other Q outputs. They can't get past the filter, but Q output 10 now can pass safely through the filter. So if I have an object here, it will potentially go out of this mark. So filters filter influence, and most of the time, if you use one at all, you're going to just block everything, but you can pick and choose which Q outputs can get through the filter. Okay, this is a relatively realistic map that we've been building here. And let's talk about that second type of map, a more abstract map. Let's open one that I already built here. What do we have here? This map with a background image should hopefully give you a hint immediately of what would happen when you play around with this map. The map is using a patch which only has two audio outputs for the device, left and right channel, but added some Q outputs that have effects on them. And because maps are routing to Q outputs, we can be routing to outputs with effects. So I have a left with a distortion on it, a right with a distortion, a left with a reverb, and a right with a reverb. I've placed them all on this map, and now I have this fun abstract space to move my object in. Let's play our test object and now listen. We could look at a heat map, but now let's actually just listen to how this map works. I've picked a file to play for my test file. I've given it some volume and I'm going to play it. A green dot is going to show up on my map where my test object is. Let's try it out. Okay, it's right in the middle. It should be equally mixed between left and right. If I move the object right, okay, we're in the right, we're in the left. Let's try up and down. Oh, some crunchy distortion in the left. Crunchy distortion in the right. Get some reverb in the right. Reverb in both. Reverb in left. And clean again. Okay, this is fun, right? You can imagine all kinds of abstract spaces and panners that you might build that don't represent a physical room at all. And again, why have I put these filters here? If we take the filter away for a moment and we look at the heat map, once again, we have the situation where the influence of the upper marks was going to bleed into the lower part of the map. I didn't want that. I added the filters back, and it keeps the influence of the marks in the parts of the map that I wanted to have. I could also have played around with shadows to have a similar effect. Okay, that's an abstract map. We can also combine them. Let's go back to my original My Cool Theater. I'm going to delete these marks and filters. I happen to have a screenshot of the blueprints of our research theater here in Baltimore, the voxel. I'm going to drag them onto this map. It will tell me, do you want to resize your map to this image? Yes, I do. And now I have a background image for my actual theater. If this were a light colored image, I could invert it to make it prettier around the eyes, but it started out dark, so I'll leave it that way. And now I have some really accurate ground plans that I can use to place my objects on this map. So I could go in and say, I happen to know there's a speaker at this grid position, and there's a speaker at this grid position, and so on, which is very fun stuff. And I could create a quite accurate map this way, but I could combine it with the idea of the more abstract map, and I could say, all right, well, these are just my clean, simple speakers, but let's say if I'm moving an object beyond the set of speakers, I want to still hear it coming out of that speaker, but with a little reverb. I could create a Q output that is routed to the same speaker, but now has the reverb effect. So if my object goes in that direction, I hear it localized to that part of my room, but as it goes further, it sort of goes off into this distant reverb that maybe fades out with a filter or something like that. So I can combine realistic stuff with artsy design stuff in one map. And it really all boils down to give it the example that I want to give about what it should sound at this location, and it'll figure out how to transition between them. Fun. The only thing we haven't talked about yet then is map objects. What are map objects? Let's take a look at map objects. We're going to add one. It is just an object that you can route sound to that is owned by the map. If I open up the monitor, we should see, yep, it's on the monitor because a map object is always running, always active. Any queue in the workspace can send audio to this object. It's always there. This is the kind of object that all other products have. They have these global, kind of constantly running objects. Because QLab has queues, we also have queue objects, which are owned by and exist only within individual queues that can only get audio from that queue. So we have two kinds of objects. We have queue objects, which are owned by queues and only exist if the queue is running. And we have map objects, which all queues can send audio to and are always running. Okay, so that is how you set up a map in QLab. There are more tricks you can find if you really dig in. There's some fun ideas you can play with, but that should give you the tools to really get in there and make some cool maps. So I recommend download it, try it out, see what's confusing, ask us questions, email support@figure53.com if you have questions, and we will do our best to answer them. And I hope you have fun. It's pretty fun.